Okay, let's get started. Welcome. This is the first StepUP webinar. It's entitled Designing Deep Renovation for the Decarbonisation of the EU Building Stock. We have planned this to take roughly 1 hour, depending on how long the Q&A section at the end goes. And you have signed up, so you have seen the agenda, but just to quickly recap it for you, you can see all the other speakers have their webcams on right now, and I will come to introduce them as they go through their part of the presentation. But first, I will give a quick introduction. I'm the StepUP Project Coordinator from IES. I'm a Senior Project Manager in R&D, and I will give you a very quick overview of the project. I'll then hand over to Melinda Orova from Abud. We'll talk about the StepUP methodology. Then Laia Casas from Eurecat will discuss the importance of data collection. We will then go in specifically in detail on the plug-and-play renovation technologies that we're developing as part of StepUP. So on this, we'll have two presentations, one from Esther Caldana from Money Group and one from Morten Weisdonnerup from Sunterm. Finally, we will be looking at how to collect specifications and technical aspects to ensure a successful deep renovation, and Anna Bataille from Eurecat will close the presentations. We expect to do this in roughly, let's say, 40 minutes or so, 50 at most, and then we'll have so that we can then have a Q&A session. Please make sure to use the chat, the question section of the GoToWebinar, the question functionality, so that if you have a question that arises during the presentations, we can deal with it when we get to the Q&A part of the webinar. So without further ado, let me give you a very, very quick overview of the StepUP project. So the project is funded by Horizon 2020 program of the European Commission. We have been working on the project now for almost 2 years. Apologies. And it's a project of, let's say, middle size. It's roughly 5 million euro budget. We have a small enough consortium. It's 10 partners, but we are from 7 different countries. And it's a consortium that's very, very focused on industrial companies, as in particular innovative SMEs. So we represent in the consortium the whole value chain. The main focus of the StepUP project is the renovation investment. So this is the core point, the core reason for us to work on this research project. We want to make sure that deep renovation becomes a reliable investment, an attractive investment, a sustainable investment. So there's many aspects to this. We want to minimize the performance gap, reduce the investment risk, and maximize value for the investors. So the whole project is focused around developing solutions that are applied within the scope of a methodology for deep renovation with these objectives. What are those objectives in particular? Of course, said the first one, the overarching one, is to make renovation more attractive and reliable. This is through a methodology, and this is the one that Melinda Orova will present. Then the methodology is declined in 4 other main objectives. The first is to reduce the performance gap, so ensure that the difference between modeled and real is very small. Optimize the renovation investment through innovative financial models. Minimize the time on site by using off-site pre-assembled technologies, and accelerate the renovation market by having interoperable, compatible products for renovation. The 4 main solutions of the StepUP project are the plug-and-play envelope and the plug-and-play smart heat solution. These 2 will be presented in detail later by Esther Caldana and Morten Weisdonnerup. We also have 2 other main solutions, which are the innovative financing tools and the software tools We're not going to present this in detail, but you can browse our website for more. And of course, we'll do later webinars on this. We are going to test and implement our solutions in 3 pilots, a virtual and 2 real pilots, representing the vast amount of buildings in Europe. So we have public non-residential buildings from a school in Hungary, rental office buildings in the UK, and the multifamily residential housing in Spain. Again, today we're not going to discuss the pilots, but this is something that we will definitely discuss in another webinar later. And I will leave you to recommending to go on our website to see more, follow us on Twitter and LinkedIn for more. So that said, I will now hand over the presentation to Melinda Orova, who's a senior consultant in Abud, and her focus is on energy efficient building design. She does work a lot on LEED and WELL building certification, a lot of R&D work too, and life cycle analysis for BREEAM and other assessment systems. So in StepUP, she is coordinating the renovation methodology and the pilots work. So I'll leave it to you, Melinda.
Thank you, Julia. Can you see my screen with the presentation? Thank you, Julia, for your introduction, and I would like to briefly present the methodology that we developed for more effective and successful deep energy renovations in this project. And if you go to the next slide, for the methodology, I would like to highlight the 4 main principles that we considered during the methodology development. At first, that we were based the methodology on an iterative incremental process, which means that we are trying to cover every phase of potential energy renovation and consider renovation as a process and not a one-time action during a building's lifetime. We also aim for a data-driven approach, as Julia mentioned. So we include a long-term data collection and monitoring before, during, and after the renovation as well. We are also considering the stakeholders' needs and priorities during the renovation process, and not just the project initiators and the stakeholders who has the final say in a project. And we also consider that we need to make renovations more approachable and attractive for investors. So we are not only considering the energy benefits of renovations, but also we are assessing the non-energy benefits of the different energy renovation measures. Because this can make renovations more feasible for stakeholders. If you go to the next slide, I would like to quickly show you what are the scope of a potential StepUP project, a StepUP renovation project. We are considering a set of stakeholders who are general stakeholders in a normal renovation process. We also consider the a set of energy conservation measures, mainly the two technologies that we are developing in this project, the plug-and-play envelope and also the smart heat system. And also we have a list of technological and operational energy conservation measures that we consider, which also fit with the two main technologies and which can also be assessed with our set of key performance indicators. And as Julia mentioned in the introduction, we are mainly considering three building types. And just to show you the what kind of performance measures we are using, we have a set of key performance indicators, and we develop these indicators based on the different benefits, energy and non-energy benefits that comes from implementing different refurbishment measures. And in the next few slides, if we go to the next one, I would like to show you the StepUP methodology step by step and briefly introduce you what are our main goals in each step. And starting in the feasibility phase, if we go next slide, in the main goal of the feasibility phase, this is a brief phase where an owner or a project initiator can decide if a renovation project is feasible or not. This is based on by deciding an initial energy conservation measures list, and this is then studied briefly, and we develop a feasibility study, a financial study, and also the project initiator should consider if the StepUP method is applicable for their project or not. This is mainly the consideration of the technical aspects of the different technologies that we are developing in the project, and based on these two information, the project initiator can decide on pursuing the renovation with the StepUP method. And with this starts the next phase, which is the preparation phase, where the main goal is to define the main targets of the project. For example, if the project is targeting the mainly energy savings or comfort improvement or cost savings, and also during this phase, the other goal is to collect and organize all the data which is needed for the design phase, and this data collection can take a long time, because ideally we consider that 1 year of data collection is necessary for our data-driven approach. Our next presentation will introduce you to this data collection methodology that we consider. And after we collected all the necessary data, we are moving on to the design phase, where during the design phase, the current state of a building of the building that is intended for renovation is assessed, and based on that, the different refurbishment scenarios are considered, which include the different energy conservation measures. And with this, we can calculate the key performance indicators for the different scenarios, and also for the different scenarios, the business case is developed, which presents the costs and the potential savings of these different scenarios. And also with this business case, the aim is to propose a plan for actually financing the implementation of the renovation scenario. And for this, the main approach is to use the savings from each renovation cycle to finance the next the implementation of the next renovation measure. And if we go to the and at the end of the design stage, of course, based on this information, the final design and the most appropriate feasible design is selected. And during the implementation phase, the procurement and implementation of these different measures is conducted. And at the end, there is, of course, we also consider the operation phase where the data collection is also happening continuously, and based on the information coming from the monitoring system, the operations are optimized, and the performance is also needs to be adjusted. And also, this is the phase where the next renovation cycle can be decided if to go forward and to prepare for this phase. And at the end, I would like to show that we have a lot of supporting tools to carry out this methodology. Mainly, there are overarching guidelines that we developed and also will develop during the project. For example, there is a methodology for there will be a data management and lifecycle platform that supports the carrying out of the methodology and supports mainly the design. And also there are space-specific guidelines that we are developing. For example, we are developing the business case. Business case plans that projects can use, and also, for example, we are developing installation guidelines for the technologies, so it should be a comprehensive methodology for everyone to use. And at the end, I just want to let you know that the first draft of a public draft of this methodology is available on our website, and every feedback is welcome. Please get in touch with us through the website, and thank you.
Julia, you're muted.
Thank you. Yes, I noticed. Yeah. Thank you, Melinda. So as I was saying, we're running a couple of minutes late, but I think we can recover. We'll now move on to the presentation from Laia Casas, who is has a background in physics and engineering. She's been working in construction, innovation in construction for 15 years now, and in particular for 9 years in Eurecat, especially on research projects. So Laia is going to present the data collection and building monitoring aspects of the project.
Thank you. Thank you for the introduction, Julia. And then we are going to talk about the importance of the data collection and the building monitoring. Then, as you have seen in Melinda presentation, the data, the real data, is important for the StepUP methodology. But what kind of real data we are going to talk about here? In the StepUP methodology, we have 3 kinds of real data. We have historical data from current buildings, such as utility bills. We have real data coming from sensors and meters from the current state of the building and after the renovated building. trying to have at least 1 year of monitoring data. And there are also user data data from the users by survey. And why is important this data coming from sensors and meters devices? It's important because it helps us to know what is the real consumption, the energy consumption of these buildings, and the levels of comfort before, in order to know the baseline of the state of the performance of the buildings, and after the implementation works of the energy conservative measures. It also help us to continue to understand where the building performance and the building system operation and the user comfort. Also to verify the expected impacts of these energy conservative measures, for example, like reaching the decarbonisation that it is expected to get in the project, and also to reduce the energy performance gap, the difference between the design performance and the real performance of the buildings. And also, this data help us to carry out a continuous commissioning of these energy conservative measures. And also, with this data, we are improving the score according to the Smart Readiness Indicator scheme adopted by the European Commission. And what we need to collect and to build the monitoring of the buildings. For this data infrastructure, we need two requirements. Basically, we need the metering and monitoring devices, and we also need the communication and network technologies. The metering and monitoring devices are instrumentation used to measure and record physical parameters like temperature, relative humidity, energy consumption, etc. And the communication and network technologies are part of the data infrastructure used for the data transmission in the case of the StepUP technology and the methodology, to the data management platform. For the StepUP project, the metering and monitoring devices are the ones that are detected for the energy conservative measures. As I said, the electricity and the gas consumption, in the case of the energy consumption, we can find a lot of kind of energy meters. We can actually, there are a lot of buildings with smart meters, but we can also find in buildings which are being renovated meters that has been installed for a long time, so they are not the smart ones that can be found. And there are devices in order to read the energy meters, right? Regarding the ambient conditions, we have sensors all in one that records the air temperature, the median radiant temperature, the indoor air velocity, the relative humidity, the indoor air quality, the occupancy, movement, the ambient light, and the weather conditions. And there is also an important device, the one that is the data logger, in order to logger the data locally, right? Okay.
Laia,
And
can I still wrap up in 2 minutes, please?
okay. In order for the communication and network technologies, there are nowadays there are a list of different technologies. They are wired and wireless, and there are a lot of the current energy meters that has adapted this that can be connected with these communication and network technologies, as well as the available and commercial sensors, which can with IoT, no, Internet of Things, that can be connected with internet. And these specifications for these technologies are the flexibility, the scalability, the easy deployment and maintenance, the reduction cost, the construction cost, etc. No, and well, the most used nowadays is the wireless technologies, because they have a lot of flexibility and scalability and easy deployment. They are low cost devices. So here we can see a scheme of the data architecture of the monitoring system that we have in one of the pilots. This has been validated because we are already getting monitoring the data from the building of Pamplona, the pilot, the Spanish pilot. Although it is not the final scheme, because we in this scheme we are not gathering the data locally, but we, in this case, we are sending the data to the internet, to a server by the gateways between the sensors and the internet, and then we are reading and getting this data by a data logger, and then send it to the data management platform. Okay? But I repeat, this is not the last configuration, but we have to improve it. But it is real. We have this installed in the Spanish pilot. Here are some pictures of the Spanish pilot, the ambient sensors, the energy meters, the weather station, the gas monitoring, the heat meter, and the gateways that send the data to internet. Right? And
Can
also,
I ask you to wrap up, please?
yes, it's the last one. Yeah, sorry. And this is the last slide. In the project, we have developed a protocol for the data collection. Mostly of these steps are in the preparatory phase. All the first all the 6 points, in order to have the baseline of the performance of the building before the renovation works, identifying the requirements, designing the data scheme, the architecture, installing, connecting the data to the data management platform of the project, ensuring that we are getting these measurements and they are right. And then we have the acquisition in the implementation phase, adjusting the data, and then collecting this data after the renovation works. And well, if you want to have more information about these data with infrastructure requirements, we have developed a deliverable that is available in the StepUP website. And that's all. Thank you very much for your attention.
Thank you. Thank you, Laia.
Thanks.
There's a lot to discuss, a lot to say about this, but we need to move on for sure. Now we go to the technologies presentations. The first one is Esther Caldana from Money Group. She's an architect working in the ISOPAN technical department. So she works with architecture and design firms to develop suitable solutions for their needs. And Esther will be presenting the Facade technology.
Okay. Good morning to everyone. I am Esther Caldana, and I'm working. Oh, but do you see my screen?
Yes.
Okay. And I'm working in ISOPAN. As maybe someone of you know, ISOPAN is part of Gruppo Manni, and our core business is the production of sandwich panel. So we try to design this plug and play solution for the renovation of facade. And our solution is based on a corpus study and analysis of the building. And in our idea, the building can be compared to a car, which is initially assembled, then tested, and eventually put on road. In this view, study and planning, scheduling, maintenance activities is very important and crucial. This design is based on survey that more detailed as possible, that must show the building in all its parts. Then we must find a rhythm or a modularity that can be transformed in some elements. And we have also to find the bearing structure of the building able to support the new technology. But what we are designing is an industrial technology. So we have to know that this solution can have many values and benefits, but such as well as some limitation. And so in some for example, in loggias or balconies, we have to use more conventional solutions. We identify these 5 concepts as a sort of guide during the development of this plug and play solution. They are tailoring, lightness, speed, aesthetic, and modularity. Lightness, because the new system must be light and not encumber on the existing building on which it will be installed. tailoring and modularity seems in contrast, but they are not, because it is very important to look for modularity in buildings, the survey of the building in this way play a very fundamental role, because it allows us to define all those elements that will be placed on the building. Speed, because we want to reduce as much as we can the time in the construction site, and finally aesthetics, because the use of different kinds of coating or finishes allow us to be able to respond to some designers or environment needs. So the module is composed of three main elements. We have an anchor system, a 3 millimeters galvanized steel profile, and then a ventilated facade composed of a sandwich panels, some steel or aluminum profile, some brackets, and finally a facade panel or cladding. It is also possible to install windows and all the elements, or such as flashing and protection elements. Here you can see three different kinds of modules. I know that maybe they seem incomplete, but they are not, because we decided to leave some part of the cladding to be installed inside, in order to be able to respond to some problems due to the installation on the construction site. We call them jolly modules, and so when we first install all the modules, then we have to take the correct jolly modules, and finally fixing these jolly modules. In October, we realized and constructed this an ideal steel facade, and this facade was not constructed in a perfect way, so we can see that it simulates a sort of concrete wall, or the wall of an existing building. And we realized 6 modules, and we decide to simulate the installation in our plant in Verona. We obtain a very good result, because in 5 hours we can install about 48 square meters. This is a very short videos, but I think it is very representative. So we installed the first 3 modules, then the other 3, and finally the jolly modules, and this is the result.
Thank you, Esther. Thank you. And
thank you.
Yeah, and this video is also on our YouTube channel, so you can watch it again there. think we can move on to the presentation from Santerm. Morten Weisdonnerup will be presenting then the smart heat technology.
Yes, hello.
Hello, Morten.
I am.
You think you're welcome. It's not.
You see my screen now?
You see the screen, but not you. Oh, there you go. Hello. So
And also
Morten
me.
is the yes. So Morten is the CEO and co-founder of Santerm. He's been working on PCM for with based storage solution within Santerm for the past 7 years. Before that, he was working in electronics, and he will now give us a brief introduction to the technology.
Okay, thank you. First of all, I'd like to explain why we at Santerm focus on storing thermal energy. I think this picture from the European Commission very well sums it up, that about 80% of all the energy is used in our homes is actually used for space heating and water heating. In that way, it makes very good sense to store excess energy as thermal heat, because most likely we will pretty soon need it anyways. Of course, during the summertime, there is periods where we do not need a whole lot of heating. A brief explanation about the Santerm system. It is all built around the thermal battery in the center of this diagram. We call it a thermal battery, or a thermal storage. It is based on phase-changing materials that makes it very compact compared to conventional storage systems. In the smart heat concept or smart heat product, we do have products out and running in single-family houses, but in the StepUP project, we are looking more at it as a concept where we can take individual components and scale up to fit into the buildings. But in the concept, we have a heat source, most likely a heat pump that can run on excess electricity, either from the grid, from wind turbines or solar, or from locally produced solar or yeah, in rare cases wind or other renewable energy sources. The smart heat system is connected to the cloud, where we constantly look at the forecasts. We look at the forecast of the electricity costs, so we can schedule the production of the heat from the heat pump to the most ideal times. It's on one hand the cost of electricity, and on the other hand the outside temperature. So most cases it makes sense to produce when the electricity is cheapest, but in rare cases it actually also makes sense to produce when electricity is expensive, but the outside conditions make it very favorable to run the heat pump. We also look at the rhythm of the building and monitor, and our artificial intelligence adapt to when does the building consume large amounts of domestic hot water, to ensure that we do have sufficient hot water on stored for the times. And of course, we monitor both the outside and the inside temperatures of the building to make the system adjust for everything. The thermal storage is a physical small size, but has a very large capacity. This is pretty much sums up what I just explained in the diagram. So I will skip through that to catch up a little bit of time, hopefully. I said that the thermal storage is quite small. Usually when I'm presenting this, I have the possibility to hand out some small hand warmers with our logo on them. These are more or less a gimmick, but they very well explain what kind of energy storage system we are working with. One of these hand warmers has the energy content about the equivalent of a cup of coffee. If we take the equivalent, about 10,000 hand warmers, it's about the same as 5 domestic sized buffer tanks, or about 5 times as much as you can fit in most regular houses. but that's actually the capacity we have available in one sun-term thermal battery. With our system, we also have the intelligent controller where we constantly monitor the state of the building and the temperatures inside, so we can adjust for the amount of energy that is being fed into the building. That means that if you have a south-faced facade with a lot of windows, you will get a lot of free heat into the building. And if you have underfloor heating, as we have a lot of here in Denmark, we will see the pattern that the thermostats will close down the temperature once it is too hot in the building. With our control, we will turn down the underfloor heating maybe 4 or 5 hours before the sun starts to shine into the buildings. So the floor is cooled down once the free energy is coming. And the same happens in the afternoon, where we turn up the heat in the afternoon while the sun is still shining, just to make sure that once the sun is gone, that we can have a nice and warm floor. This is of course also especially in the winter season. Right now we are all looking at cooling, as much cooling as we can. Of course, the controller is also looking into optimizing the heat production, as I shortly explained earlier. The heating management system is one of the new components that we're looking into for the StepUP project. We do have zones in our single-family houses, but when we're looking at an apartment building, we could have maybe 40 or 50 zones, or maybe even sub-zones with a living room and a bedroom for each apartment that we are able to individually control. We do have a centralized building manager dashboard where the janitor or technical responsible of the building can go in and check all the essential metrics of the heating system, so we ensure that we have a well running system. We also integrate with smart devices with thermostatic valves. We use LoRa for communication, as it provides a long range. We also interface with underfloor heating systems, for instance, Vavin, that we communicate with on Modbus. Then, of course, a large range of sensors can be integrated into the system. Meters for heating and electricity for us to monitor and optimize the system. In some cases, we could also offer to some billing services for the building owner if that is required. When we're looking into the smart heat StepUP solution, before we can start working out this custom solution, we need to know what is the current heat demand for the building, what is the future heat demand after the renovation, when money and other companies have made their contribution, so we do not dimension a system that is too large for the building. We also need to know the peak demand on the coldest day, either by calculation or by experience. And one of the more beneficial metrics is how much of renewable energy contribution is from the building. So are we able to put on PV systems on the roof? PV systems and thermal storage makes very good sense together. The expected outputs of this will give us a heat pump with just the right size. In many cases, when you dimension a heat pump based on guesstimates, you end up with a heat pump that is too big. That of course it's more expensive, but also the operating costs of a heat pump that is too big for the building is very poor, or can at least be very poor. We are also able to calculate the ideal thermal storage size. Of course, how much space is available in the building, and also what kind of storage size is ideal for the amount of renewable energies that is available. in a few cases, we have seen that we have actually shaved off a couple of months of electricity requirements on the building simply by utilizing locally installed PV. This is an example of the system that we are configuring for one of the pilots in Hungary for the kindergarten. We have in this case a heat pump, and we have two storage vessels, one for heat and one for cooling, because in this case we actually also providing cooling system for the kindergarten. This is another example from a previous system that we have installed in a building similar size to the kindergarten, where we have a 45 kilowatt heat pump installed on the outside, and the thermal storage and control system installed on the inside of the building. The concept of StepUP is that we are able to fully build and configure this on either a container or a truck beds that can be delivered and installed in maybe a matter of a day to install an entire heating system. I think that's pretty much sums up the smart heat contribution to the StepUP.
Thank you very much, Morten. We now move on to the last presentation. This is Anna Bataille from Eurecat. Is going to introduce the specification and technical aspects for the technologies for deep renovation. And Anna has a background in architecture and robotics. She's been working now for a while in Eurecat on robotics and construction technologies, some pretty exciting stuff. And in the project, she's leading these technical interaction of products in what we call the plug and play protocol. So
No.
close the webinar for us.
Yeah, I'm gonna try to go quickly through the presentation. So first, I'm gonna explain a little bit why it's important to collect specifications of the different components and products that take part in the project. I'm gonna quickly go through the StepUP technologies, the principles that we are considering for the project, the specifications itself that we have started to draft, and finally, I'm gonna talk about the technology provider cluster. So for the specifications, one of the aims of the project is to develop tools that can allow and facilitate this renovation market. And within these tools, the one that is related to the specifications, it's the protocol. We are going to find a protocol for intercompatible, interoperable technologies. And in order to do that, we need to know which are the requirements for the different components that take place during the renovation process. So the technologies of the StepUP project have already been presented. There are like two main technologies. One that is aiming to reduce the energy dependency of the building, and the other one is trying to make more efficient the active system of the building. So what we have identified is that the partners within the project can provide a certain part of these technologies, but in order to achieve a proper renovation, there are some technologies that that other companies would have to provide. And here we can see which are these technologies. From the passive system, we need external layer, we need high performance windows and solar protection systems. And for the active system, we need solar and thermal panels, heating and cooling system, and the demand controlled ventilation. So once we have identified which technologies we also need in order to develop the project, there's something that we question, it's like, what do we want to achieve as a project? Which goals do we have? So we define certain principles that these identified technologies need to comply with in order to achieve the goals of StepUP. I'm gonna go through them quickly. I think we're really running out of time. So the first one would be industrialized components. So we need them to be preassembled off-site. That they save time on site, and they are low intrusive in order to not disrupt the uses of the buildings. We need them to be customized so they can adapt to different architectural geometries and different aesthetics. We need to be compatible and interoperable so we can integrate and play, with the different components depending of the requirements of the building. And then there's like the ecological impact that we also want to take it into account during the project. And the fifth principle is that which is to define, like the information that need to be exchanged between the different stakeholders and partners within the different stages in order to guarantee that it's a fluent communication. And the sixth steps is related to certifications and regulations in order to comply with European and local from the different countries standards, and also environmental certificates. So from these principles that we believe are necessary to achieve the goals of StepUP, we've extracted certain requirements that need to be complied in the system level and at the component level. The system level would be like the solution that the components provide, and at the component level, it's each of the components that the companies provide, which specifications they need to have. So here what we can see, it's like from these specifications, depending on the component, if it's the part of the external layer or the heating system, with the specifications they need to comply with, so they can interact with the project that we are developing. And finally, the technology provider cluster. So as I mentioned before, these technologies can be provided by the partners itself. So we are looking for companies that they can provide, these technologies and participate in the project. So what are we looking for? What are we aiming that these companies can provide us is a feedback that the specifications that we are defining can be met by the market. And what we are offering to them, it's networking, visibility, also like a real case scenario where they can test when they can test, these innovative solutions in real case scenarios. And finally, I went super fast, but we are collecting this in a document that we are going to share with you, so you can go through the specifications and the different details on how to collaborate with us in depth.
Thank you, Anna, and fantastic.
I don't know if it's been too fast.
The time, no, perfect. You just brought us almost at 3:30. Right now, I don't see any questions in the form, but if you have any, write them in or raise your hand if you want to ask us something. Or of course, you can, from the website, you can just write us, especially after you've looked at the documentation that you can find also here in the handouts. And if you have any questions, we'll definitely address them also after the webinar, whenever you just get in touch with us. So I'll just give it a couple minutes to see if there are any questions. Again, you can raise your hand as well, so you can just voice your question if you want. And in the meantime, maybe I'll just ask everyone to turn on back their cameras just to say goodbye. Yeah. Okay. So I see no raised hands and no questions right now. We must have been very, very clear, explained everything perfectly. Again, I invite you to visit our website, stepup-project.eu. You can download both the methodology and the data requirements. The deliverable, those reports are both public, and we do welcome your feedback on them. We do see, yeah. I see some, yeah, thanks in the questions, so some thanks for the session. But again, you can also use the contact form on the website to get in touch, and we'll answer any questions that you may have. Goodbye and have a good afternoon. Thank you for joining us.